Hello students, this is lecture 5 on unit 5 metal corrosion, its prevention and electrochemistry. In this lecture we are going to discuss about the preventive methods for corrosion. Talking about corrosion control, nowadays as we have already studied that the losses due to corrosion measures in crores of rupees. So nowadays more focus is given to the preventive methods used for control of corrosion of the metals. So there are different protective measures that can be done. First one is modification of environment, second cathodic protection, and third one use of protective coatings, that is metal coatings. Talking about first way of controlling corrosion is the modification of environment, which can be done either by removal of corrosion stimulant from the atmosphere or by using a corrosion inhibitors. To prevent corrosion from oxygen, deaeration can be done or by adding reducing agents like hydrazine or sodium sulfite. To prevent corrosion due to acids, the acidic medium can be neutralized with lime, which is an alkali. And to remove the salts from the surrounding environment, ion exchange resin can be used. And also to prevent the corrosion due to moisture, dehumidification can be done using silica gel. So in this category, the metals are protected from corrosion by the removal of corrosion stimulant. Second way of modifying the environment is the use of corrosion inhibitors. Corrosion inhibitors are the organic or inorganic substances that form a coating film on the metal surface which acts as a physical barrier between the metal and the surrounding medium. The substances that can be used as inhibitors are quinolines, organic amines, cyanides, chromates are effective inhibitors that can be used. For example, potassium chromate, when added to the medium, it stops the corrosion of iron and other metals by oxidizing iron to ferric state and forming a protective film of insoluble oxide over the anode surface. Second method of prevention of corrosion is cathodic protection. The principle involved in this method is to force the metal to be protected to behave like a cathode. Thereby corrosion does not occur. There are two types of cathodic protection. One is sacrificial anodic protection and second is impressed current cathodic protection. Let us know more about sacrificial anodic protection method. The metallic structure to be protected is connected by a wire to a more anodic metal, which is active, by an insulating wire so that active metal itself gets corroded slowly, while the parent structure, which is to be protected from corrosion, becomes cathodic and it gets protected. The more active metal so employed is called as sacrificial anode. Whenever the sacrificial anode is consumed completely, it is replaced by fresh one. The more active metal itself undergoes corrosion as it becomes anode and it sacrifices itself to protect our desired structure, hence it is named as sacrificial anode. After the complete consumption of sacrificial anode, it is replaced by another fresh anode. Metal commonly used as sacrificial anodes are magnesium, zinc, aluminium, and their alloys. Sacrificial anodes are used for the protection of buried pipelines, underground cables, marine structures, ship hulls, water tanks, etc. So that's the first way of cathodic protection, by using sacrificial anodic protection. This is the diagram in which this is the structure which is protected from corrosion, which is connected by an insulating wire to a sacrificial anode which is more active than the parent structure. So magnesium is more active than Fe. So here magnesium will act as sacrificial anode, and iron will act as, that is iron underground pipeline will act as cathode. So forcefully this structure to be protected from corrosion is made to behave like cathode, and it is protected from the corrosion by sacrificial anodic protection. The same is shown practically here. This is an underground pipeline which is connected to the sacrificial anode by an insulating wire so that it is protected from the corrosion. Second way of cathodic protection is by impressed current cathodic protection. An impressed current is applied in opposite direction to nullify the corrosion current and convert the corroding metal from anode to cathode. The impressed current is derived from a direct current source like a battery or rectifier on AC line with an insoluble anode like graphite, high silica iron, scrap iron, stainless steel or platinum. A sufficient DC is applied, that is direct current is applied to an insoluble anode buried in the soil or impressed in the corroding medium and connected to the metallic structure to be protected. The anode is buried in a backfill such as coke prees or gypsum to increase the electrical contact between itself and the surrounding soil. Now, in this method, externally the current is applied in the opposite direction to nullify the corrosion current. So anode, the metal which is to be protected from corrosion, is converted from anode to cathode by applying current. And mainly this particular method is used for protection of the bigger structures. This type of protection is used in buried structures such as tanks and underground tanks and pipelines, transmission line towers, marine piers, lead-up ships, etc. So bigger structures can be protected by this impressed current cathodic protection. The advantage is they can be automatically controlled, which reduce maintenance and operational cost. Now here anode does not undergo any corrosion. So it does not have to be replaced by another one, as the current itself acts in the opposite direction to nullify the corrosion current. So it can be automatically controlled, that reduces the maintenance and operational cost. This is the method of impressed current cathodic protection, which is shown here. This is the structure, that is tank, storage tank, which is to be protected from corrosion, which is connected to the anode, and with the help of rectifier an impressed current is applied so that this structure becomes cathode, and inert electrode like graphite, it becomes anode. Similarly, the same is shown in this diagram also. So the bigger structures can be protected by using impressed current cathodic protection. In these images also they are shown. For such bigger structures, impressed current cathodic protection can be used, like transmission towers, tank, this is a storage tank. So impress current cathodic protection is generally used for the protection of the heavy big structures from corrosion. Thank you.